All right, so in the previous video, I talked about position, velocity, and acceleration and kind of did a more informal analysis of this problem. But in this video, I want to do a more formal analytical analysis of this motion, answering some questions as you could see them on a worksheet or a test. And I'll remind you how to solve the necessary equations and inequalities that you would need to do to solve a problem like this. So first of all, I have the same information on the screen, some of the same information on the screen that we had last video. We have the position function, the velocity function, and the acceleration function. Okay, so I'm just going to go ahead and get those very, how do I want to do that now? I'll just underline them like I did there. So there's position, that one there. See, velocity was this one here. Acceleration is this one. So we'll use those when we need them. So the first question I want to ask about this problem is, when is the object at rest? So at rest means stopped, like not moving. The thing that tells us if the object is moving or not is its velocity. This is really a question about velocity. In fact, at rest means that velocity as a function of time is equal to 0. So if we take our velocity function, set it equal to 0, that's going to form an equation. And then all we need to do is to solve for t, because the question is when, right? Which would mean, like, what are the time values when the velocity is equal to 0? So I'm going to write this equation. It is our velocity function, 3/2 t squared minus 12t plus 18 equals 0. So now let's just try to solve that. So the first thing I would want to do is simplify this significantly by multiplying by like something to simplify the coefficients. So I'm going to take both sides of this equation. That's 0 there. All right, that looks like a 0. I'm going to take both sides of this equation and multiply it by 2/3 times 2/3 times 2/3. Now I want to distribute that multiplication across the addition and subtraction there. But I chose 2/3 because then when I multiply 2/3 times 3/2, those will cancel, right? So what I'm going to get here is just 1t squared. And then minus, you can perform this multiplication for yourself. You can double check. You're going to get 8t and then plus 12. That will equal still 0 on the right. So that is a much simpler form of the same equation, like equivalent to what we started with, but it's much easier to think about. So let's see if we can factor that, right? If we can factor this, then we would be able to solve it quite easily using the 0 product rule. So how does it factor? I believe this factors like t minus 6 and t minus 2. Now that's right, because -6 minus 2 is 8. And -6 times -2 is 12. So now remember that the 0 product rule says that if these two things multiplied together give you 0, well, one or the other of them must be 0. And this leads us to two possible answers: 6 seconds or 2 seconds. Okay. Now in the last video, we happened to evaluate the velocity at 6 seconds. And we're choosing to do it every 3 seconds. All right, so in the last video, we already found this information, but that was sort of by chance. The way we did it in the last video is not an analytical way to do it, and it's not a very rigorous way to do it because it was guesswork. Like, I just got lucky, and I happened to guess the right t values, and I found 2 of them. But how do I know that I found all of them? When I ask you when is the object at rest, if you're going to do a full, complete solution of that, you need to find all of the values and make sure that you found them all. So this method, like truly solving this equation, like analytically like this, ensures that you found all of the points and the exact time values where the object is at. Okay, so now we're going to answer the next question. During what time intervals is the object moving forwards? This is an inequality problem in disguise. So let's see, it says moving forwards. Moving forwards is just another way of saying that the velocity as a function of time is positive. That's another thing that it's saying. Okay. So that's an inequality. V of t is greater than 0. So really all I want to do here is just take my v function. There it is. It's over here. That thing. And I want to go ahead and copy it over. Then I want to write greater than 0 and then solve that inequality. So so really what I can do to solve this, I could do some algebra on this, and I could probably use this factorization we had earlier, but that's there's a more straightforward approach to solving inequalities that you may have learned in a pre-calculus class. It's called a sign chart. So I recommend using a sign chart. The sign chart goes like this. Figure out all of the places where the function might cross over the x-axis. There's two types of ways that can happen. One is that it has a 0. So if the function actually equals 0, then it could cross over the x-axis, right? Like an x-intercept. Or it could have a discontinuity, some sort of point where it's undefined. At a discontinuity, it could jump over the x-axis, like this is the x-axis, it could jump over it. Or it could have like a vertical asymptote and then sort of go to infinity and then come back from negative infinity, like teleporting via infinity over the x-axis. So we want to find anywhere where it is 0 or undefined. However, the function we're working with, these functions actually are polynomial functions. And one thing we know for sure about polynomials, they're never undefined. They have no discontinuity. So really, all I need to look at are the zeros, which I very conveniently already found in part A. So what I can do is I can make a sign chart. I'll say this is the sign chart for velocity. Starts at 0 seconds because we're really we're not taking into consideration time values before 0 seconds. And then I want to plot the zeros having at 2 and 6. So it's 0 at 2 and at 6. And then in between that, I form these intervals. And what I want to do is pick a test value in each interval and then just check to see if the function's positive or negative, right? Our v of t function. So you can pick like 1 in this interval, maybe 3 in this interval, and I don't know, 5 in this interval. And then we're going to evaluate v of 1. And we'll find, I'll leave it to you to actually like plug this in your calculator, but you'll find that v of 1 is positive. So we have a positive value here. V of 3 is a negative number, so it's negative here. Oops. Negative here. And v of 5 is positive again. So it is positive here. So because we've already identified all of the points where it equals 0, 2, and 6. Since we found that it was positive at 1, it's actually positive everywhere on the interval that 1 was represented. And that's due to the intermediate value theorem we learned back in chapter 2. Can't cross over the x-axis anywhere other than the 2 points we already found. So if it's positive at 1, it's positive everywhere on this interval. Now we can answer our question. During what time intervals is the object moving forwards? Well, it's going to be this interval and this interval. So our answer is going to be anything from 0 here, anything from 0 to 2. And I'll use parentheses because I don't actually want to include 0 and 2. I'll just say in between 0 and 2. And then anything greater than 6. So 6 to, I guess, infinity. Sure. Okay, if we had asked, alternatively, if we had asked on what time intervals is the object moving backwards, then we would answer between 2 and 6, because that's when it. All right, so the last question is, during what time intervals is the object speeding up? So I explained last video, speeding up means that the velocity and the acceleration are working together. They're working in the same direction. So this means we're looking for either v of t positive and a of t also positive, or v of t negative and a of t also negative. So one way to solve a problem like this is to make a sign chart for each of the two functions and line them up next to each other. Okay, so real quick off to the side, I'm going to figure out when a of t equals 0. A of t is 3t minus 12. I can see that over here. Right? So 3t minus 12 equals 0. This is going to happen when 3t equals 12, so t equals 4. And then to make a of t sign chart, I'm going to go from 0 out to whatever. And here's 4. 4 is my 0, so I'll plot it like a filled in point here. 4. And then I'll pick a number to the left and a number to the right. And you can evaluate a of 2. It's going to be, 3 times 2 is 6 minus 12 is negative 6. So it's a negative number. Negative on this interval. And then a of 6 is going to be 3 times 6 is 18. Oops. Minus 12 is positive 6, so that's going to be positive. So positive on this interval. So I'm going to take that sign chart and I'm going to line it up next to pretty much already. I mean, I'll make a copy of the V sign chart that we had here. It went to 2 and to 6, and it was positive, and then negative, and then positive again. So if I line up the two sign charts next to each other, I can look for the intervals where they're either both negative or both positive. So if I sort of color code here, here's a negative interval, here's a negative interval. And we can see right here between 2 and 4. Right? I forgot to put these numbers on here, but this is 2, this is 6. So I lined the 2s up and the 6s up, right? So we can see here between 2 and 4, they're both negative. So one interval that we're going to answer is 2 to 4. And then where are they both positive? It looks like, this is positive here in blue. This is positive, not over here. They're not both positive here because one's positive, one's negative. Here again, in this interval, 4 to 6, both positive. Oh, one positive, one negative. But over here, we see we have, for any value after 6, we have acceleration is positive and velocity is also positive. This is when you're off to the races after you've grabbed your keys and you're running forwards again. After you pass 6 seconds, you're accelerating forwards. Okay, so that is how you can solve some problems like this more analytically using sign charts and by solving equations to find zeros of functions.